just in case we decide we want this. Okay. So I have to factor the numerator and the denominator. So I'm going to get, on my numerator, I will have, what will I have?
X minus 6, X plus 3.
X minus 6, X plus 3. And in my denominator, I'm going to have X minus 4, X plus 3. So from this, I can determine the domain. This is my function here. My function is not this. This is not my function. This will be my function in lowest terms. But my function is the entire thing. So if my function is the entire thing, then for my domain, I can't have 0 as a denominator. So I can't have x equal to 4, and I can't have x equal to negative 3. So my domain has got to be restricted from both of those. Make sense? Okay, good. Okay. Now when I want to write this in lowest terms, that's when I can cross these out. So I'm going to have x minus 6 over x minus 4. And that is my function written in lowest terms. Are we okay with that? Questions? Ask me as I'm going along. Okay. Y-intercept. I need to find the Y-intercept. I want to find the Y-intercept. So where Y-intercept means x equals 0. Just write this function over here. I have x squared minus 3x minus 18 over x squared minus x minus 12. I just want to make sure I have that where I can read it easily. Okay. So I'm going to plug 0 in for x. So I'm going to get 0 squared minus 3x. Oh, I'm sorry. 0 squared minus 3 times 0 minus 18 divided by 0 squared minus 0 minus 12. So that's 0, that's 0, that's 0, that's 0. I have minus 18 over minus 12, and that reduces down to 3 halves. So I have a y-intercept of 3 halves. You okay with that? Questions? No? Okay. So x-intercepts. That's the next one, Duffy, right? Okay. X-intercepts. So where I'm trying to find an x-intercept, y equals 0. Okay. So if y is equal to 0, I have my original function here. I have x squared minus 3x minus 18 over x squared minus x minus 12. I set y equal to 0. If I have a fraction and it's equal to 0, all I'm really concerned about is whether the numerator is going to be equal to 0. I just need to set the numerator equal to 0. And the reason is this. If I multiply both sides by x squared minus x minus 12, which is my denominator here, I will be able to cancel out my denominator. And this is going to be equal to 0, because everything times 0 is 0. So really, I'm just looking at my numerator of x squared minus 3x minus 18 is equal to 0. So where I solve for x, that's going to tell me where my x-intercepts are. Well, I already know that I can factor this, because I did it up here, into x minus 6, x plus 3. So let's go x minus 6, x plus 3 is equal to 0. So that means I'm going to have an x-intercept at 6, And this is telling me also at negative 3. Those would be my x-intercepts. Except, I have a problem with this one here at negative 3. And my problem is, I know that at negative 3, that would make my denominator 0. And like the overriding, most powerful thing going on in these rational functions is that the denominator cannot be equal to 0. So there's no way I can have an x-intercept at negative 3 if that would make my denominator 0. So I'm only going to have the one x-intercept, which is going to be right here at 6. That's going to be my x-intercept. Are we okay with that? Questions? No? Okay. All right. Let me do this. So as I was going along, so I know I have an x-intercept at, was it positive 6?
Yeah.
Positive 6. And I have a y-intercept at negative 2, right?
3.
Was it
3.
negative 3?
Yeah.
Is that right? Negative 3? Okay, negative 3 is a y-intercept. Okay, so I'm just kind of talking to...
Oh, 3 over 2.
Pardon me?
Negative 3 over 2.
I'm just trying to say that again, please.
It was 3 over 2.
Oh, 3 over 2 is my y-intercept. That's it. Thank you very much. It's positive 3/2. So right there. That's my y-intercept. Okay, so I put a couple points there on my graph. Vertical asymptotes. Okay, so vertical asymptotes is where Mr. Ducky here can't get past the wall. No matter what he does, his head's just getting higher and higher and higher. Vertical asymptotes. And that means he's at a spot on the road, a spot on the x, which just can't exist. So the vertical asymptotes and the domain are very closely related. These are the items here where I initially thought, these are the items that are excluded from the domain. So if an x value is excluded from the domain, it's going to be either a vertical asymptote or a hole. One or the other. There will never be an x value where it's going to make the domain 0. And the way you know whether it's going to be a vertical asymptote or a hole is whether or not it canceled out when we put it in the lowest terms. If it canceled out, it's going to be a hole. If it didn't cancel out, it's going to be a vertical asymptote. So I'm going to have a vertical asymptote at 4 on this graph. Go back to my graph. I know I'm going to have a vertical asymptote, so let's make our vertical asymptote in red at 4. Now I also know that I'm going to have a hole over here at negative 3. I'm going to put a hole there, but that isn't really where the hole goes. I'm just making a note to myself that there's going to be a hole there in the graph at negative 3. That would be a hole on the axis. We're not going to be on the axis. Yes?
I don't understand why there's a hole. I thought you said it was supposed to be one or the other.
It is. So my two things that were excluded from my domain were 4 and negative 3. So at 4, it's either going to be a vertical asymptote or a hole. And at negative 3, it's going to be a vertical asymptote or a hole. Make sense? So it's not, you can have multiple vertical asymptotes. You can have multiple holes. Okay? But each one of these numbers that's restricted from the domain is either going to be a vertical asymptote or a hole. Good? Okay. So I found my vertical asymptote at 4. Now I need to find a horizontal or oblique asymptote. Well, going over to my function again, I see that my function is improper. But it's just regular improper. It's not really improper, and it's not extremely improper. It's just regular improper. So if it's regular improper, it's easy to find the horizontal asymptote. The horizontal asymptote is leading coefficient of the top over the leading coefficient of the bottom. So in this case here, my leading coefficient from the top is 1. My leading coefficient from the bottom is 1. My horizontal asymptote is going to be at 1. The horizontal asymptote is 1. So let's go to my graph again. And we're making asymptotes in red. So my horizontal asymptote is going to be right here. At 1. Now, with horizontal and oblique asymptotes, you're only going to have one of those. You're not going to have multiple horizontal asymptotes. You're not going to have multiple oblique asymptotes. You're only going to have either a horizontal asymptote or an oblique asymptote. Now, if it is a rational function, meaning like a function fraction, you're always going to have one or the other. You're always going to have some kind of a, no, I don't want to do that. I don't want that. I want my TI. There we go. You're always going to have a horizontal or oblique asymptote, or if it's extremely improper, you'll have a different kind of an asymptote. But you're always going to have one of those kind of things, but only one. So you can't have more than one horizontal asymptote. You can't have a horizontal asymptote and an oblique asymptote. It's just going to be, one of those types. Are we okay with that? Yeah? Okay. All right. So my horizontal asymptote in this case is at 1. And now I have to identify any points where the graph of R intercepts any of the asymptotes. So I have two things I'm trying to graph here. What's that? Go away, please. There's two things I need. I'm going to have my graph of my function. I don't know what that's going to look like yet. But I do know what the graph of my horizontal asymptote looks like. It's y equals 1. So I'm going to set my function x squared minus 3x minus 18 over x squared minus x minus 12. I'm going to set it equal to 1. This is going to give me the graph of my function. This is going to give me the graph of my horizontal asymptote. I want to see if they're going to intersect. Is there going to be any spot where they're going to be the same x value? Okay. Let's multiply both sides by my denominator. So let's multiply this whole equation here by x squared minus x minus 12. And let's multiply this side over here by x squared minus x minus 12. So I get this, my denominators cancel out. I get x squared minus 3x minus 18 is equal to x squared minus x minus 12. So I'll start off by subtracting x squared from both sides. Because I can see that's going to make it go away. So it goes away there and it goes away there. And I'm left with negative 3x minus 18 is equal to negative x minus 12. So I'm going to add 3x to both sides because I like positive numbers. So that one's going to go away. And this is going to be negative 18 is equal to 2x minus 12. And so now I guess I'll add 12 to both sides. And I get 2x is equal to negative 6. And I divide by 2. And I get x is equal to negative 3. So that's telling me that's where I should have an intersection of my graph and my horizontal asymptote. Except there's a hole at negative 3. I can't have any x values at negative 3. See, if Mr. Ducky here was riding along and the graph had a hole right there, instead of his neck stretching, he would fall down into oblivion. Right? He would just fall through the hole forever, right? And that would be it for him. Except it's a super magic car, so he kind of figured out how to get back on the other side of the hole, right? But, so I found that where, if there was going to be an intersection where it would be, but that's a hole. So there is not going to be an intersection. That was on a number of the exams. People wrote no intersection, or they don't. There's not a point where they cross. But I didn't see any work. So you got to kind of show me how you figured it out. Okay. So we've got all these points here, and now I'm gonna graph my function. So I'm gonna go y equals. I'm gonna clear that, and it's equal to parentheses x squared minus 3x minus 18, and that's all divided by x squared minus x minus 12, and I go zoom 6. And this is looking kind of like what my graph is supposed to look like. I can kind of see how it fits onto what I've drawn. So I'm going to just sketch it in. I can see that I have my horizontal asymptote is at 1. So I'm kind of going along here, and it's perfectly fine, and it crosses right there at 3/2, because I know that's my y-intercept, and then it gets stuck on the vertical asymptote and goes up. And instead of coming down on that side, we start on this side here, and we're going up, and it crosses at the x-axis, and it just now keeps on going out for the horizontal asymptote, like that. And then the only other thing I need to add to this graph is I need to go like this, make my hole right there, erase it off of my axis, and there we have it. Any questions? Are you sure?
The whole thing.
The whole thing?
I thought you just placed the hole there randomly and you just didn't come back to it.
I did. I originally put it because I knew it was going to be a -3, so I just drew it right there. But the hole isn't on the axis. The hole is actually on the graph.
Yeah, how did you know that there was going to be a hole there?
I knew there was going to be a hole there because when I did my calculations for domain, I knew that I couldn't have 4 or -3, but the -3 canceled out on the top and the bottom.
Oh, so that's why.
That's why. If it cancels out, it's a hole. It's not an asymptote. Yeah? Questions? Let's